Okay, so chapter 6.1 is exponents. And gonna be real with you, there are a lot of rules, okay? So we go through a whole bunch of different just ways to deal with exponents. And it's really important that you understand all these rules because eventually you're gonna have to simplify and do all of this so that you can apply it and graph this stuff, okay? The big overarching thing is over here on the right, okay? So for exponents, you're always gonna simplify. So if you have something like 5 squared, don't just leave it as 5 squared, simplify it to 25. And we'll talk about how to solve this, but if you had like the same base, one on top of the other, you wouldn't leave it like that, you would simplify. Okay, and then the other thing is you always want positive exponents. So if you have a negative exponent, you're just not done yet. You need to solve and get your answer to have positive exponents, okay? So those are the two big things we're gonna be looking at no matter what rules we're doing, all right? But a fun little review of a vocab lesson first, okay? If you had 4 squared, okay, with my horrible handwriting, just so we remember, the 4, the big number, is called the base. And then up here, that's your actual exponent, right? The squared, all right? And just to jog our memory, 4 squared means 4 times 4, right? This is 4 two times. This does not mean 4 times 2. Please don't do that, okay? This is always something that happens on the test, so don't let this be you, all right? If I had like x to the 5th, this means x times x times x times x times x. It means 5 x's multiplied by each other to get x to the 5th power, okay? There you go, just basic vocab. The base becomes important because we need to look at things that have the same base as we go through here, all right? Okay, special cases are when you have 0 as your exponent. Exponent, right? So no matter what I have, if I had 5 to the 0 power, 18 to the 0 power, x to the 0 power, 5,821 to the 0 power, okay? Anything raised to the 0 power is 1. That's always your answer. So it doesn't matter. 18 to the 0 power, 1. X to the 0 power, 1. Giant number to the 0 power, 1. Okay, everything raised to the 0 power is 1, except 0 to the 0 power. Okay, this would just be like a trick question that someone would give you, but you can't take 0 to the 0 power. So if you see this, this is undefined or no solution. Okay, or whatever. I can't think of any example like this in your book, but just in case you ever see 0 raised to the 0 power, that's your exception to the rule, okay? Other than that, anything raised to the 0 power is 1. So if you ever see something to raise to the 0 power, that's like, hooray, you don't really have to calculate anything, it equals 1. Okay, now on to way more difficult stuff, all right? Negative exponents. So if I had like 4 to the negative 2 power, okay? This looks scary and awful. And one of my rules is I always want to have positive exponents. So I don't want this negative. And the way I like to think about it is that your negative exponent tells you that your base number is unhappy and he needs to flip. He needs to be the reciprocal. Okay, hopefully you remember what, I spelled that right, okay? Reciprocal, we did this in chapter 4 when we were doing parallel and perpendicular lines. Perpendicular lines have the negative reciprocal slope of the original line. Reciprocal just means flip over your numerator and denominator. Okay, that's the kind of basic idea, right? So if I have 4 to the negative 2, 4 is a whole number, so really this is 4 over 1 to the negative 2 power. That negative 2 power tells me, okay, this base number 4 is unhappy being on my numerator. He needs to flip and be the reciprocal and be on the denominator. So I'm just gonna flip him, okay? And this 1 is gonna go up top, So 1's on my numerator, and now I have 4 on my denominator, which has now changed my -2 exponent to a +2 exponent. So if you have a negative exponent, you're just flipping your base number, you're flipping the reciprocal, and then that exponent becomes positive. So now I have 1/4 squared, and I want to simplify. This will be 1/4 times 4, to be 1/16. Okay, so that would be my nice simplified answer with a negative exponent. Okay, let's look at some more examples. If I had 1/x to the -4th, okay, this tells me my base of x is unhappy being on the denominator. I have a -4 exponent. I need to switch it. This needs to flip to be on my numerator. So I'm going to flip this up. So I'm going to have x to the +4th over 1, because 1 flips to the denominator. This is just x to the 4th. Okay, not too terrible. You could have it so that there's multiple things. So what if you had 5 to the -2 power divided by y to the -3 power? Okay, it's saying both of these bases are unhappy. This 5 doesn't want to be in the numerator. This y doesn't want to be in the denominator. They both want to flip-flop. So I'm going to have y to the +3rd power divided by 5 to the +2 power. And I'm not quite done yet because I didn't simplify. So if I was getting this, correct and most simplified, this would be y cubed divided by 5 squared is 5 times 5, which is 25. Okay. We'll do one other one, which is, let's do x to the -3rd divided by 4 squared y to the -4th. Okay. In this case, you're looking at your 4. It already has a positive exponent. You want to keep that 4 on the denominator. But my x needs to flip and my y needs to flip. And I need to get reciprocals of those two things. Okay, so my y is going to come up top. So I'm going to have y to the +4 divided by, my 4 is going to stay down here on the denominator, 4 squared. My x is going to come down. So that'll be x +3 for positive cubed. And I'm not quite simplified, although I ran out of space. Okay, but 4 squared is 16. So this should be y to the 4th divided by 16 x cubed. Okay, so negative exponents, although they look weird and scary, all they're doing is just telling you, hey, my base is unhappy. It doesn't want to be on the numerator. Or, hey, my base is unhappy. It doesn't want to be on the denominator. You need to flip it and get it in the reciprocal. All right? Good. Next rule is a product of powers, okay? So product is when you multiply, okay? Product is multiply. And what are we multiplying? We're multiplying the same base. Okay, so when you are multiplying things with the same base, then that means you're going to add their exponents. Okay, and we actually know this intuitively, but let's look at some examples. If I had 2 squared times 2 to the 4th. Okay, if I was just using my product of powers, I have the same base, 2 squared times 2 to the 4th. They both have the base of 2. Ooh, and really important part here is you keep the base the same. All right, so one of the things I see students do is they'll go like 2 times 2, and then they'll end up with a new base of 4. Don't do that. Your base stays the same. So your base is still going to be 2. And now your exponent, since I'm multiplying the same basis, I'm just going to add my exponents, 2 plus 4. Okay, so I should get my answer of 2 to the 6th. let's try it out, okay? I could literally write this out. 2 squared is 2 times 2, right? 2 to the 4th is 2 times 2 times 2 times 2. Okay, I've got 2 squared and I've got 2 to the 4th. If you look right now, and I'm multiplying this by this, I have 1, 2, 3, 4, 5, 6 2s. I literally am going 2 to the 6th. Okay? Hopefully this makes sense. It works out. You could even like solve it mathematically and go 2 times 2 is 4. 2 times 2 is 4. Times 2 is 8. Times 2 is 16. And you could go 4 times 16 to figure out that this should be, what, 64? Am I making this up in my head? Probably. And you could plug in your calculator and see what is 2 to the 6th power, and you go 2 to the 6th power, and you should get 64, assuming that I can do math, which is always a toss-up, okay? But this is why. This is why I add my exponents, okay? So it doesn't matter if I have a number as my base or if I have a letter. I could have like x to the 6th times x to the 3rd, okay? Same base, x times x. I'm gonna keep my base the same, and then I just add my exponents. 6 plus 3 is 9. So I have 6, I have x to the 9th power. Okay, hopefully not terrible. Product of powers. Next, okay, is quotient of powers. All right, quotient is when you divide. And we're dividing things with the same base. Okay? So it's basically the opposite, right? Product of powers, you're multiplying the same base, so you add the exponents. Quotient of powers, you're dividing the same base, so you subtract the exponents. Easy peasy. And again, you keep the base the same, right? Keep your same base. So if I had 4 to the 6th divided by 4 to the 4th, okay? I have the same base of 4. 4 is my same base, and then I have my exponents 6 and 4. So what this is saying is, this is saying 4 to the power of 6 minus 4. Numerator minus denominator. So that would equal 4 squared. But I wouldn't leave it like that. I would simplify, and I would say this is 16. Okay? I could have x to the 18th divided by x to the 7th. And this is saying, okay, I'm dividing the same base of x. I'm going to subtract my exponents. Numerator minus denominator. 18 minus 7 is 11. So this should be x to the 11th power. Okay, I could give you a trickier one. That's x to the 5th divided by x to the 11th. Okay, same process, all right? I'm dividing here, x to the 5th divided by x to the 11th, same base of x, except now my larger exponent's on the denominator. Okay, if I was still just like following this same rule, this would be x to the 5 minus 11, which would be x to the negative 6th power. Negative 6, the negative exponent tells me my base is unhappy. It wants to be the reciprocal. This is going to be 1 over x to the 6th. Okay. Box my answers here so it doesn't look so cluttered. If this makes sense to you, great. Or you could look here and you could say, I'm going to subtract, right? 5 and 11. 11's the bigger number. I'm going to end up with my difference for my exponent on the denominator. I'm going to have my x to the 6th on the denominator, not on the top. But even if you literally just went 5 minus 11, you'd get negative 6. So you'd know to put that base with its exponent on the denominator. You got to get the reciprocal. Okay, hopefully not terrible so far. only one more rule, okay? This is power of a power. So you're now going to raise an exponent to another power, okay? I think that's the raise something with an exponent to another power. Okay, and when you do this, you're gonna multiply your exponents. And you do not need the same base for this, okay? The same base is not necessary. So if I had like 4 to the 6th power raised to the 3rd power, okay, so I'm taking this exponent and I'm raising it to another one, I'm going to multiply those two exponents together. So this would be 4 to the 18th power. 6 times 3 is 18. Now technically, I should simplify this and get this out into whatever an actual number is. That's gigantic. I'm not going to do that. Okay? If I had a to the 4th raised to the 2nd power, this is a to the 4 times 2 is 8. So this is a to the 8th. Try and keep the colors consistent here. If I had multiple things, like 5x squared y to the 3rd, all raised to the 3rd power, you literally will distribute this exponent, okay, to every single term within the parentheses that you're raising it to. So the 3 is going to be going to the 5, the 3 is going to the x squared, and the 3 is going to the y cubed. It's an ugly arrow, but you know what I mean. Okay, so this is going to be 5 cubed times x squared to the 3rd power, so 2 times 3, so x to the 6th, and y cubed to the 3rd power is 3 times 3, so y to the 9th. And then I'd want to simplify this. 5 cubed is 125, right? So this is 125 x to the 6th, y to the 9th. Okay, so you distribute that exponent. All right, let's just do a couple of tricky practices and then we'll call it good. Okay, if I had 2x to the negative 2, y to the 3rd, divided by 3x, y to the negative 4th, all raised to the 4th power. This is like applying all of the things, okay? The first thing I would do is I would deal with my negative exponents, okay? So I'm not even gonna look at this to the 4th power yet. I'm just gonna say, okay, this x squared needs to come down. This y to the negative 4th needs to go up. So I'm gonna have 2y cubed times y to the 4th, because this is going to come up on my numerator, divided by 3x, that stayed the same, times your x squared is going to come down to the denominator. All of this raised to the 4th power. And before I raise everything to the 4th power, I'm going to do my product of powers first, okay? So I have y cubed times y to the 4th, same base. I'm going to add these exponents. This is going to be 2y to the 7th divided by 3, same thing here. These are the same base. X to the first power times x squared, so this should be x cubed. All of this raised to the 4th power. Now I can distribute this 4th power. And it's going to go to the numerator and everything to the denominator. What's the nicest way to draw this without... Okay, it's going to go 4th to there and to there. All right, so my answer is going to be 2 to the 4th power, y to the 7 times 4, so y to the 28th, divided by 3 to the 4th power, and x 3 times 4. x to the 12th. Okay? And I can simplify these numbers. 2 to the 4th power. 2 times 2 is 4, times 2 is 8, times 2 is 16. This should be this should be 16 y to the 28 divided by 3 to the 4th is what, 81? Yep. 81 x to the 12th. Okay, this is hot. This is, look at how many things that is. That has negative exponents, that has products, that has all kinds of stuff. Okay, let me do one more, and then we'll call it good. Okay, let's do a horrible one. 3x to the negative 5th y squared divided by 4x to the negative 2 y to the 0 squared. Let's make it really hard. Times x y to the 4th divided by 9y squared. Okay, first thing I would do is deal with my negative exponents and literally change nothing else. Well, except for the y, because this is y to the 0, so that's 1. Hooray! This is just a 1, y to the 0. Thanks, y to the 0. So I have 3 y squared divided by 4 x to the 5th, and this x squared goes up top, x squared times 2, and then I'm not going to change anything in here yet, so times x y to the 4th divided by 9y squared. Now I'm going to deal with my subtraction, right, because I've got an x squared over x to the 5th, so this will be 3y squared over 4x cubed, because 2 minus 5 is negative 3, so that x cubed is going to be on my denominator, squared. And same thing here, I've got a y in the denominator and y to the 4th on my numerator, so 4 minus 1, so I'm going to get x y to the 3rd power, 4 minus 1 is 3, divided by 9 squared. Okay, now there's nothing I can do to simplify other than distribute all of my squares. So I'm going to get 3 squared is 9, y, 2 times 2, y to the 4th, divided by 2 squared, 4 squared is 16, x to the 6th, times x squared, y to the 6th, divided by 9 squared is 81. Okay, I've run out of space, so we're gonna move that up. And, okay, now we just kind of, you could multiply everything across, you can combine everything. You have 9 x squared, y to the 4th times y to the 6th. I'm gonna add those exponents, so y to the 10th, divided by 16 times 81, x to the 6th. This will reduce 9 and 81, so this is going to be a 9 down here. X squared and x to the 6th, so I could subtract. Right, so this x squared goes away. This will be x to the 4th. And I should get a final answer of y to the 10th over 16 times 9. Yeah, there's no way to reduce that. What is 16 times 9? 9 times 6 is 54, 9 times 1 is 9. Okay, so 144 x to the 4th. And that's your final answer to that horrible multi-part equation. Okay, if you can do this, you can do anything. Okay, it's long enough.